Hello and welcome to my channel. Today I thought we'd look at some of the upgrades I did to my lathe. Let's get into that. One of the upgrades I wanted to talk about or show you is, I'm kind of eager to show you because it's been a long time. This lathe has been down for a while. If you follow me, know that I put a 1 horsepower AC motor on it and a variable speed changer. It's all mechanical. I'm still not sure if I like it or not. One of the things I wanted to show you is how my 1 horsepower AC motor affected this little machine. I thought we'd start out by showing you how you turn this thing on and how you make it work and whether it even works. Here, let me show you this. I don't know if everybody seen the video where I show you where the motor is. Down there, the motor, to adjust the tightness, and then it goes up and about goes to the variable speed unit. My handle. I need to still make an indicator. And then that belt goes up and into this right here. And from there, let me go around the other side. And from there, that shaft goes behind this old motor guard and goes up to the high-low speed. There's a pulley on the end of it. And then inside the head, there's gears. That's what this is hooked up to right here, high-low. So there's a pulley that goes from here down to this shaft to this 7-inch pulley. The 7-inch pulley goes down to the variable speed pulley. Variable speed pulley goes down to the motor. Power to the machine. Forward and reverse and neutral. Power on and off to the motor. And like I said, neutral, high, and low. All right. The power to the machine is down here. It's this switch. It lights up when it's on. This switch, this goes from forward to reverse. And this actually turns the motor or the power onto the motor. But all of these have to be on first. Power's on to the machine. Send forward. Power to the motor. It doesn't run. That's because it's in neutral. I have a high-low gear on this. High, low, and neutral in the middle. If I turn it on now, it'll run. When I want to move this spindle to adjust stuff, put it in the neutral and you can spin it. I believe that's as slow as it can go. I have to look down here because I did not put an indicator on there yet. It appears as it's as slow as it can go. Like I said, that was as slow as it can go in low gear. If I put it in high gear, goes to neutral, then the high gear. Forward. That's as slow as it can go in high gear. I have the big chuck on it, so I don't really want to go too much faster. I probably can, but I'm going to have to test that theory. Okay. I thought I'd show you, it also goes in reverse by switching this. Neutral, reverse, neutral, forward. And of course the high-low gear, neutral, neutral. I have everything in neutral, so when I'm messing around with it, I could even turn off the power to the machine down there. Or I can unplug everything, which would be the safest thing if I'm taking things apart. Anyway, with the little motor that came with the machine, I was able to take some 50,000 cuts. That was off the diameter using this tool. And it really cut nice. There were some beautiful finishes on there. That was with aluminum, like I said. So I thought, seeing I knew I can do that, maybe we'll put a piece of aluminum in there. Where the heck's my, there it is. And we'll see how this cuts. I think I'm going to start with a 25 thousandths cut. Then I'm going to do a 50 thousandths cut, 75, and then a 100 thousandths cut. That's off the diameter. Let's do that. Okay, power's on to the machine. Forward. Put it in high gear. It's the slowest it can go in high gear. Let's make a little mark on my part and then dial in 25 thousandths. I am on 0 here. I'm going to dial in 25. That doesn't seem to be a problem. Okay, I'm going to go in 50 thousandths. $50,000 seems to be okay. I'm going to just go to 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Seemed to do it. I went in 25, then I went 50, and then I went 100. So right now, if I just continued on with this cut, that should be 175. Let's make it 200. 10, 25. That's 200 thousandths. That was 200 thousandths. I'm going to take 250 thousandths. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 20, 30, 40, 50, 60, 70, 80, 90, 200. 10, 20, 30, 40, 50. That's 250 thousandths off the diameter. Let's see. It seemed to have stopped it. I'm not sure which. This is so I could look at my pulley. I'm not sure which pulley stopped. It appears that it's the pulley that goes from this shaft to the spindle. I'm going to have to tighten that up. I do have a belt tightener that I had made, but I'm not sure if that's even going to work. I don't know if you remember when I made the special designed pulleys. I may change that and go to a V-belt pulley, 1/4 inch V-belt, or back to the pulley that was on it was like a timing pulley, so it can't slip. Well, I hope I never have to take a 1/4 inch off or something at one cut. It was leaving a decent finish, and even at 200 thousandths. But I'm going to have to look into it. That's the first time I did that. Let's see what I could take off the front of it. Let's close this. About 1/8 of an inch of a face. That was about an 1/8 inch face cut. Yeah, that's about a 1/8 face cut. But it was aluminum. I'm almost afraid to do steel only because of that belt slipping. I hope it's the belt slipping. So, put it in neutral there. Put it in neutral there. We did a 1/4 inch off the diameter for about 1/8 of an inch before the belt started slipping. I hope that was the belt and not the gears. It was probably the belt. The belts up here were still spinning. That means the motor and everything else was spinning, but the chuck stopped. So that means the belt that goes from this shaft up to the spindle, or up to the high-low gear, was slipping. I'll look into that. I do know one thing. I have an excessive amount. I don't know if you can see that. It's probably 100,000 of backlash in there. So I was thinking of doing some work on my saddle. The cross slide, the compound slide, but that's a different story. But for now, I think this video is coming to an end. So until next time, enjoy.